We're going to go ahead and take a look at one more style of problem dealing with z-scores. Suppose we go back to those young men's heights, which are once again a mean of 70, standard deviation of 2.5, and they're normally distributed. Question is, how tall do you have to be, or short, depending upon how you look at it, to be in the lower 10% of the men? So in other words, we'd have 10% here. How far over do you have to go before you would get to the edge of that 10%? This is really a reverse z-score process. So when you're going backwards to find that data value, when you're given a proportion, you want to go ahead and start out by finding your proportion in the middle of your z-score chart and then using your reverse z-score formula, which is right here. Now, formulas you're going to be using here are your forward z-score, and then if you're looking for a particular data value, that would be this one over here, which is a reverse z-score. Occasionally you'll be doing the reverse process where you're looking for the mean, but typically you're not going to use the middle one. You're going to use the one on the left for a forward z-score, the one on the right for a reverse z-score. So, how tall must you be so that you're in the lower 10% of the men? Well, you know your mean is 70. Your standard deviations are 2.8. You might be wondering, where does your z being a negative 1.28 come from? Well, it comes from looking at your table in the back of the book. You want to go ahead and look in the middle of your table and find a point 1. Now, 10%, just a second here, 10% is, when you write it as a decimal, 0.10. So we need to go ahead and find a 0.10 in the table in the back of the book. So we got to look for a 0.1. Well, let's see. 0.1 would be about right here. You notice here that this one here is 15 below your 0.1. This one here is only 3 above that, so we're going to choose this one here. So you want to look at the z-score for that. So that z-score is in this row and in this column. So you know it's a negative 1.2 and then it's an 8 after that. So that's how we end up knowing what our z is. So when you're doing a reverse z-score process, you look in the middle of your chart in the back of the book to work backwards to find the z-score. You then use that z-score into your formula here. So you can multiply these two together, take your mean then and add that to your mean, and you get 66.42. So in other words, a man in that 18 to 24 age group would have to be 66.42 inches taller or less, shorter than that, to be in the bottom 10%. So let's go ahead and look at the women's heights. Normally distributed at a mean of 64.5, standard deviation 25. What is it for the 25th percentile? So in other words, we're looking for how far to the right do you have to be so that this area is 25%. Well, once again, since you're looking for that data value, you're given your proportion, it's a reverse z-score process. You need to go ahead and find your 25th percentile, which is a 0.25 in your table in the back of the book. When you're looking for a 1 point, or not a 1.25, but a 0.25, it doesn't show up. However, you'll realize a 0.25 is in between these two right here. Now, here you're 17 below, here you're 14 above. So this one here is slightly closer. So it's a negative 0.6, and then it's in the 07 category. So it's a negative 0.67 for your z-score. So we'll go ahead and use our z-score formula, plugging in our mean of the 64.5, plugging in our z-value, which we said was a negative 60 or negative 0.67, and then we'll plug in our standard deviation, which we said was 2.5. When we type that all into our calculator, we get a 62.825. So the 25th percentile of women's heights is 62.825 inches or 5 feet 2.82 inches.